Hello, this is Mr. Henry, and welcome to Lesson 0.2, Rational Numbers as Fractions and Decimals. The essential question says, how do I convert rational numbers into fractions and decimals? So that's what we're going to do. We're going to take rational numbers, that's all we're going to see in this lesson, are rational numbers. Those are the nice, pretty decimals and fractions. And we're going to be able to convert them and change them into fractions and change them into decimals. Okay? The did you know down below says, did you know that every number can be written as a decimal? Even the irrational ones. But not every number can be written as a fraction. That's kind of the definition of an irrational number. An irrational number is a number that you cannot write as a fraction. In most cases, if you evaluate or do the math, it will convert a number into a decimal. So in this case, this fraction, 1/8. Well, if you do the math, that symbol right there is a division symbol. If you take 1 divided by 8, you get the decimal 0.25. Or if you have, in this case, square root of 88. If you actually take the square root of it by hitting those key presses in your calculator, right? Here's Calc-E. So to take the square root of 88, we hit second square root, this x squared button, so it makes that little square root symbol. 88 equals, and lo and behold, that's the same thing I have there. That's how you change it into a decimal. You take the square root of it. Okay? This lesson has no new vocabulary, so we're just going to get right into the lesson. Example 1. So the directions tell us to write each rational number as a fraction. So that's going to be our job. We're going to change every one of these numbers into a fraction. Some of them are very easy, some not as easy. So for example, here, the number 8. We can easily write that as a fraction. Every whole number, an integer, can be written as a fraction if you simply just put it over 1. 8 over 1 is a fraction that is equal to 8. That is done. Letter B, decimal. This is a terminating decimal. See how it stops? So there's kind of a little trick you can use here. So we can break this down into two parts. I'm going to put a line kind of right here. I lied. I'm going to make it a ghost line, a little not quite so dark of a line, a faded line. Right here. All right. Now, this side, my whole number, is going to stay, it's going to stay -3. This 56, on the other hand, that is my part that's going to change into a fraction. So the 56 is going to go on the top. Okay, it looks pretty close to a fraction already. All we're missing is this denominator down here. So what denominator would we have there? Well, there's only two really numbers we're going to put down there. It's either going to be a power of 10, 10, or 100, or 1,000, or 10,000. See, just a 1 with a bunch of zeros. These are all going to happen if you have a terminating decimal, like this guy. If you have a repeating decimal, it's either going to be 9, or 99, or 999, or 9,999. So it's always going to be one of these two to start. You go, well, how? Okay, so I need to use terminating. It's a terminating decimal. It stops. It's one of these guys. Well, how do I know which one to use? Well, you count. Here, I have 2 digits. I have to have the one with 2 zeros. 100. Let's see if I can get that faded line out of there. There. I was trying to use him as a separator, but I don't know if he's really doing any good there. So this is the fraction, -3 from the whole number, and 56 over 100. If I would type this into my calculator, I'm not exactly sure how to do it on this calculator. On your calculator, you would hit -3. You'd hit -3, and then you'd hit this fraction button. Then you'd hit 56, and the fraction button again, and 100. I don't think that's going to work for me. I think it's probably going to give me an error, because this calculator is slightly different. Yeah. Actually, I think I know. And then I put 56 fraction 100, like that. Okay. I guess that's technically true. If yours, I'm not sure if your calculator spits out the same thing. But this is a fraction. Okay. So this is a terminating decimal. It stopped, so we had to use a power of 10. And because there's 2 digits up top, we used 2 zeros. Basically, you need the denominator here that's just slightly bigger than the numerator. So in this case, it was 56, so I had to use 100. I wouldn't pick like 10,000. It's way too big. All right, letter C. Square root of 9. Well, I'd like to know what that is as a decimal first. If I can write it as a decimal, then I can change it into a fraction. So if I take on my calculator here, square root of 9, so that's second x squared, to get that square root symbol, the one right above the x squared, 9 equals, oh, that's just 3. Okay, so if that's the number 3, to write that as a fraction, like we did up here, we just put it over 1, and we're done. Easy. Okay, here's 2 for you to try. Go ahead, pause the video, try them right now. When you're ready to continue, hit play, and we'll go through them together. All right, so letter D. So you know it's going to be 9 and 3 over something. And since this is a terminating decimal, it's either going to be 10 or 100 or 1,000, dot, 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 the whole way down to, you can have a 1 with a billion zeros after if you wanted. Now, since this number up top is 1 digit long, you use 1 0. Now, while I'm thinking about this, I actually think in that last problem that we just did on the previous page, we probably should have simplified that fraction. This 56 over 100, that can be simplified. I should probably do that. One of the easiest ways to do that, especially with the calculator, is you just type in the fraction 56 fraction 100 equals, there you go. So the -3 will stay -3, and then the fraction part simplifies into, what was it, 14 over 25? There. I like that better, now that we have it simplified. You should always simplify your fractions. This guy here, if you're not sure if he simplifies, you can try it. 3 fraction 10 equals 3/10. It does not simplify, and we're done. Now, technically, this is a mixed number. It's a fraction with a whole number out front. I understand that. If you wanted it as a fraction, an improper fraction, the way that you did this a long time ago, back in, well, probably 6th grade or so, is you took the denominator times by the numerator, or times by the whole number, and you added the numerator. You kind of go in this little half circle thingy. So you take 10 times 9, which is 90, plus 3, 93 over 10. This is I guess the technical fraction for 9.3, but this is also acceptable. Letter E, 2 times the square root of 4. So you probably on your calculator started by doing 2 square root 4 equals, and it spits out an answer of 4, which is correct because the square root of 4, just the square root part, that part is equal to 2, as we saw there. Square root of 4 is 2. And we're taking that times by the 2 out front, and 2 times 2 is 4. So to write that thing as a fraction, we just go 4 over 1, and we're done. Okay. Now, we want to write each of these guys as a fraction. So let's see here. Now, these are slightly different because these are repeating decimals. So remember that trick I showed you a second ago, or a couple problems ago, where if it was a terminating decimal, you used 10 or 100 or 1,000, and you just keep adding zeros on. And I said if it was a repeating decimal, you use 9 or 99 or 999. You basically just keep adding nines. Well, that's how this kind of works. It's the same process. So we have a whole number of 1. I use whole number 1. The part that's being repeated is 29, so I throw a 29 up top. Now, which of these sets of 9s do you think goes down in the denominator? Well, use the same trick as before. There's 2 numbers up top, so we're going to use the one with 2 9s. Now, you don't believe me? You just want to verify for yourself? You want to make sure you're right? I love it. Check it. So, on your calculator, again, you could just hit 1 fraction 29 fraction 99. Or, we know this 1, when we divide this, is going to be a 1. If we just take 29 divided by 99, 29 divide 99 equals, look at that, 0.29292929. The calculator rounds. That's a 2. It's going to keep going. 2929 forever. So this is, and if we'd have that 1 out front, it would become 1.29 repeated. So that's proof, verification that this is the same thing as that. Okay, letter B. Well, we've got a 0 out front, so we're not going to, if we had a number like this, a mixed number, our whole number out front would be 0, and we don't really need that. So we're just going to erase him. All right, so since it's a repeated decimal, I'm going to take the part that's being repeated. He goes up top. Now, which of those sets of 9s do you believe goes in the bottom? Well, there's 1 number up top, so you use 1 9 down below. That's it. Check it. Clear. 4 divide 9 equals, boom, 0.4 repeated. All right. Now, letter C. I want you to take a quick pause, or I'm going to take a quick pause. I want you to see, can you take an estimated guess on what you think your answer is going to be? Before I go through it and do it, can you take a reasonable guess? Okay, well, let's see. Did you start with a negative 6 out front? 366 up top. And now, which of these sets of 9s would fit? Well, there's 3 numbers, so you use 3 9s. And if we try it out, 366 divided by 999 equals 0.366366. That's the stuff that's being repeated. And having that negative 6 out front would make this a negative 6 point that junk. So that's what this would be as a fraction. Now, I guess we forgot to see if this simplifies. Actually, we forgot to check if all of these simplify. And I think this one does, because I think those are both multiples of 3. 366 fraction 999 equals 122 over 333. 122 over 333. And that 6 is a little bit tiny for me. So I guess that's technically the better answer. I can tell you off the top of my head, I know 4/9 doesn't simplify. It won't. We can try it, but it's not going to do anything. 29 over 99, I'm pretty sure that does not simplify. 29 is a prime number. So that was actually the only one that could simplify, but it was wrong of me to assume. I should have checked each of them as I was going through to make sure they don't simplify, or to check if they do simplify. Okay? Terminating decimals get powers of 10. Repeating decimals get I don't want to say powers of 9 because that's wrong, but gets this 9s pattern. Okay, letters D and E. Go ahead and try these two. Pause the video. Take your time. Do them on your own. When you're ready to continue, or if you get stuck, hit play, and we'll go through them together. All right, so here we go. This is -2 and 7 over something. Well, since it's a repeating decimal, I know it's going to be over 9s. How many 9s? Well, 1. 1 9, because it's just 1 7. And if I try it out, 7 fraction 9 does not simplify, and 7 divided by 9 gives me that 0.777777. The calculator rounds. That's why it shows an 8 there. Letter E. It's going to be a 12 and something. Up top, 320. Down below, how many 9s do we need? Since it's a repeating decimal, we need 9s, not 10s. Well, there's 3 numbers up top, so I use 3 9s down below. And if we check it out, 320 fraction 999. That does not simplify. The calculator would simplify it if it could. And just to make sure the math all worked out pretty, divided by 999 equals 0. Now, again, with our 12 here, imagine there's a 12 out front here. So 12.320, 320, 320. The math checks out. Okay, so terminating decimals get 10s. Repeating decimals get 9s. Example 3. Show the decimal expansion of rational numbers. So for each rational number, show its decimal expansion. Basically, change it to a decimal. Round answers to nearest thousandths. So if we have some repeating decimal, we're going to round it to the nearest thousandths. Okay, so let's see here. 9 divided by 3, which you could probably do in your head and should be able to do in your head. That's just 3. As a decimal, I guess we could say, we could actually leave it as 3. Okay, I'm going to put little ghost mode here just so you understand this is the decimal 3.0. You don't really need to write plus 0. You can just leave it as just 3 though. Okay. Letter B, 1 and 2 ninths. Okay, so I know this is going to be the decimal 1 point something, right? That's our decimal point. Now, this 2 over 9, remember that pattern, if it's over 9s, then it's a repeating number, right? And the thing that's repeated is whatever's up top. So I'm going to have a whole bunch of 2s, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, repeated forever. That's what this is. So that's its decimal expansion. Now, the problem told us to round answers to nearest thousandths. So it's worth examining that. So this place value is the tenths. This place value is the hundredths. This place value is the thousandths. So this 2 right here either needs to go up or stay the same, and then everything else after him goes away. And how do we decide? Well, we look at the number next door. If this is a 5 or bigger, then this 2 would go up. Now this is less than 5, which means this 2 stays the same, and we delete everything else after it. You should know how to round by now, especially by 8th grade. I'm just mostly looking at the place values and just refreshing memory, beginning of the school year stuff. Letter C, -3 times by the square root of 16. Now, we've seen the square root of 16 quite a few times. It's equal to 4. We're going to see that. Now, if you calculated it, you didn't trust yourself, you didn't trust your own brain. I hope you do. But you typed in -3 square root 16 equals, it says, -12. That's because this is 4 times by -3 Negative 3 times 4 is negative 12. Okay, and we want to take that and we want to write it as a decimal. So kind of like the first problem here, letter A, we could say, well, you know what, we could probably leave him alone. Now, if it makes you happy, you can put it's 12.0, but you don't really need that 0.0. Okay, we've got 2 for you to try. So you're going to take these 2 fractions, you're going to write them as decimals, rounding to the nearest thousandths. So go ahead, pause the video, try them on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, so the first thing you probably did is you took this 12/19 in your calculator and you divided. Clear. Move. 12 divide 19 equals. Okay, that looks like a big ugly mess. Now we know it's rational because it started out as a fraction. See? Fraction. It's rational, even though the decimal is ugly. Okay, now I'm going to write down the first 4 or 5 digits here. So 0.63157. 0.63157. That's enough because the directions told us to round to the nearest thousandths, which is here. Tenths, hundredths, thousandths. So we need to round this 1. So we need to decide, does that 1 go up or does it stay the same? And then delete everything after it. Well, the number next door is a 5. That means this 1 is going to round up. This 1 needs to become a 2. And everything else after it gets erased. Let me undo that for just a second. I'm going to just write our new answer down here. 0.632. That's how I'll show it. That way you can see what it was and then what we rounded it to. So that 1 rounded up because the number next door was a 5 or bigger. Yeah. All right, letter E. Square root of 9. Now the square root of 9, this number up top, if you calculated it, is just equal to 3. Trust me. Clear, second, oh, come on, clear, clear, clear. Second square root 9 equals 3. Beautiful. Down below, 99. It's not a decimal yet, but at least we could type that into the calculator very easily. I could type in 3 divide 99 without any troubles. So I do. Clear. 3 divide 99 equals 0.0303. It's a repeating decimal. And it makes sense because look, we're over 99. Remember that pattern? If it's over a bunch of 9s, it's a repeating pattern. So the repeating pattern here is 030303. So I can just write that as 0.03 repeated. Heck, I guess this guy up here, letter B, I could have just wrote that as 1.2 repeated. That's acceptable. I didn't have to write 2222. 0.03 repeated. Or I guess if you went that far, 0.03 tenths, hundredths, thousandths. Yeah, you can't actually go farther because if you put a 0 here, it's kind of useless. So I guess they're both acceptable ways of writing this rounded to the nearest thousandths. So to change a fraction to a decimal, we divide. To change a square root to a decimal, we square root. You evaluate. You do the math. Okay, letter F. We want to show the decimal expansion. So this is just more of the same. Just more of those same problems. Just a little bit uglier. For each rational number, show its decimal expansion. Okay, cool. Sweet. All right, so this number up top here, this negative square root of 36. Okay, so I'm going to go ahead and do negative second square root of 36 equals negative 6. And the denominator stays the same. It's just 9. I didn't do anything with them. I just kind of simplified the top. Okay, so I know my answer is going to be a negative something. Negative, now 6/9. We can just take 6 divided by 9. We get 0.66666666. The calculator rounds. You kind of always ignore that last digit. Don't put too much attention to that last digit. You kind of ignore him. I do. See, he's not there. It's just a bunch of 6s. And I don't... Yeah. So it's just going to be 0.6 repeated. You don't need to write all the 6s. You could, but this is simplified enough. Letter G. All right. Ugly. 1.5 times by this junk. Okay, so I'm going to do the square root of 81 times 1.5. All right, cool, clear, clear. Second square root 81. I'm not sure why that 6 is still highlighted, but whatever. Okay, that's 9. So this piece is 9. We're going to take that times by 1.5. I'm just going to times 9. Takes our previous answer. 9 times 1.5 equals 13.5. So this is its decimal expansion. It's already a decimal. And round to the nearest thousandths, I don't have to do that because it's not that long. So that is done. That wasn't so bad. It looked hard. It looked ugly because it had 1.5 out front. We haven't seen that before. But it wasn't so hard once we got to it. Okay, here's 3 for you to try. Take them one piece at a time, especially if they look hard. Do a step, do 2 steps. Pause the video, take the time, do them on your own. When you're ready to continue, hit play, and we'll go through them together. All right, so you probably calculated the square root down here. Square root of 100 is 10. And so you had 15 over 10. And then you take 15 divided by 10. You got 1.5. And that's it. You don't have to do anything else with it. There. I was just trying to get rid of that 6 that kept lighting up. Next one. Negative 4 and 5/9. Now, I know the whole number part here is going to be negative 4 point something. Now, I'm going to use my brain instead of using the calculator here. Because I know, I see this pattern, this 9 down below. I know this is going to be a repeating decimal, just like this was a repeating decimal. So I'm going to take the number that's up top, 5, and I know it's going to be 0.555555555 repeated forever. Okay, check it. Just to make sure we didn't make some little bogus bonehead move. 5 divide 9 equals, again, ignore the last digit. We're good. All right, letter J. You probably looked at it and go, man, that looks so hard. It's not. It's really easy. Do some simplifying. Just break it down. This is like 3 steps. Okay, so this is 5 times by this thing, and 7 times by this thing. Well, if you do this thing on the calculator, square root, second square root 25 equals 5. And if you square root 49, you get 7. So this really turns into, this fraction is 5 times 5 over 7 times 7. Well, you math that, you get 25 over 49. It's not a decimal yet, but we're only 1 step away. So if we take 25 divided by 99, because that's how you change a fraction to a decimal, you divide, we get, oopsie, whoa, not 99, 25 divided by 49. We get that. Okay, so I'm going to write down the first few digits, and then we're going to round to the nearest thousandths. So it's 0.5102. 0.5102. Now, the thousandths place is this third one. tenths, hundredths, thousandths. So this 0 either goes up or stays the same. And the number next door to it is a 2, which means this 0 does not round up. He stays the same, and everything else after it goes away. So we changed all of these ugly rational numbers into decimals. We evaluated. Okay, example 4. Problem solving. James has a cake recipe that calls for 1/3 cups of flour. What would this number be when written as a decimal? Okay, so that's a pretty straightforward question. Take the number 1/3 and change it into a decimal. Okay, and the way we've been doing that is we take the fraction and we divide. So if I take 1 divide 3 equals 0.33333333, or 0.3 repeated. That was pretty darn easy. Letter B. Beth is trying to make a new belt from a piece of fabric. Her waist is 32.25 inches. What is Beth's weight in inches as a fraction? Okay, so this is pretty much like the last problem, just in reverse. We're changing a decimal, 32.25, and we want to convert it into a fraction. Okay, so I know the whole number is going to be 32. That's the whole number out front. I take whatever's after the decimal and I throw him up top. And the only thing I have to decide is my thing down below going to be 100 or 99? Does it get 2 zeros or 2 nines? And that question really comes down to, is this decimal a terminating decimal or a repeating decimal? This guy terminates. It does not have the little bar over top. So this is done, which means I'm going to use 100. And I'm going to simplify here. I can simplify 25 over 100. That's 1/4. Calculator it. 25 fraction 100 equals 1/4. So her waist as a fraction is 32 1/4 inches. Big. Letter C. This is going to be one for you to do. It says here, Sam has a square yard with an area of 49 feet squared. To find out how much fence he would need to install to go around the perimeter of his yard, he can evaluate the expression 4 square roots of 49. Question says, how many feet of fence would he need? So go ahead, pause the video, try this problem on your own. When you're ready to continue, or if you get stuck, hit play and we'll go through it together. Alright, so he has this square yard, and it says the area is 49, and it says to find out how much fence he needs, if he evaluates this expression, if he finds the answer to this thing, this will tell him how much fence he needs. To find out how much fence he needs, he can evaluate this thing. Okay, so if we just figure out what this number is, that's how much fence he needs. So I'm going to take 4 times by whatever the square root of 49 is. And if you remember from earlier, we're going to find the square root of 49 is a nice pretty number. 7. 7 times 7 is 49. And then if we simplify here, 4 times 7 is 28. So this guy, was it Sam, or girl I guess, this person, oh it's a he, Sam would need 28 feet of fencing to go around his yard. It's a pretty tiny yard. Letter D. During gym class, students were asked to measure their heights. Don measured his height to be 62 and 7/12 inches tall. Jesus measured his height to be 62.6 repeated inches tall. The boys are trying to see who is taller. Write both measurements as fractions. Write both measurements as decimals. And who is taller. Alright, so I'll make a little table here. I've got Don, and I've got Jesus. Don, it said, was 62 and 7/12. Jesus was 62.6 repeated. Alright. So now, do the things. We want them both as, what was the first one? Fractions. Now, the cool news is, Don here is already a fraction. So I don't really have to do anything with it. Jesus here, I have to change him into a fraction. Alright, so he's going to be 62 and something. Or I know this 6 is going to be up top. So I just got to decide what my denominator is going to be. Well, I can see it's a repeated decimal. So that means down below here we need a 9. And if you try it, this will work. And we should check to see if we can simplify our fraction, which we absolutely can, because 6 over 9 simplifies down to 2/3. See? So this is 62 and 2/3. Now, if you haven't done this part yet, the second part here, change them both into decimals. When you're ready to continue, hit play, and we'll go through it together. Alright, so Jesus here is already a decimal. Or, started up here it was 62.6 repeated. And if you change this into a decimal, you're going to get the same thing. If you take 2 divided by 3, you're going to get 0.6 repeated. Okay, so he's already a decimal. Now, Don, as a decimal, is 62 point something. I'm not sure what 7/12 is. That's not a fraction I have stored in my memory banks. So I take 7, divide 12 equals, okay, 0.58 with 3 repeated. 583, and that part's repeated. Okay, okay. So here they are as both as fractions, here they are both as decimals, and the final question says, who is taller? Well, this is not easy to compare because they don't look the same. This is a fraction, this is a decimal. This is not easy to compare because in order to compare two fractions, they both have to have the same denominator. And they don't. This is a 12, this is a 9, or a 3. It just doesn't quite work out. This, to compare as a to compare which is bigger, it's very easy. You just look at the digits one digit at a time. So this first one is 62.5, 62.6. This is bigger. 62.6 is bigger than 62.5. Now, if you said, well, Mr. Henry, that's 583, and that's just 6. Well, we can expand the digits if you like. If this was 62.666, there. 666 is bigger than 583. So, you don't really have to expand it out. If you go one digit at a time, 5 is bigger than 6. The 10th digit here is bigger than the 10th digit there. So that means Jesus is taller, just by a tiny little bit. Last question, multiple choice. I think it's the last question. It says, which rational number below is closest to the value of 45/8? Okay. So, I'll be honest with you, I don't even know what the value of 45/8 is. I mean, it's a fraction, but it's hard to compare stuff to fractions. Again, because you need to have common denominators. Now, probably the first thing I'm going to do is I'm going to take this 45/8 and change it to a decimal. Okay, so that's 5.625. So now that is what I'm using as my basis to figure out if these guys are close or not. Okay, so let's start banging them out here. So square root of 49, we've seen him a couple times in this lesson already. It's 7. 7. That's not so close. Considering I can see like this is much closer, this is much closer. I don't quite know what that is yet, but I don't think it's going to be close. Next one said 3 square roots of 9. 3 times the square root of 9 is 9. Okay, that's even farther away. So I know right now this is not the closest one to that. I can see between these two choices, this is not the closest one. So it's not A, it's not B. So at least if you have those two crossed off, if you got stuck and you couldn't figure out between C and D, you take a guess. Your guess is a lot better. It's a lot better than if you had 4 choices to guess from. Now you have at least a 50-50 chance. So this is 5.5. Hopefully you know 1/2 is 0.5. If you don't know, 1 divide 2, you know, we're big boys and big girls. Over here, this is 5.9 repeated, or 99999. So we got to figure out which of these is closer. So to figure out which is closer, we're going to use a subtraction, a difference. We don't know what is the difference between here and here. A difference is subtraction. So if I take this 5.625 and this 5.5, and if I subtract them, obviously I'm not going to do it by hand. If I have a nice calculator do it for me, this difference is 0.125. That's a pretty small difference. They're only apart by 0.125. Here, I'm going to take this 5.99999 and subtract it from 5.625. Do you notice how I kind of instinctively put the bigger number on the top? Because that's how you do subtractions. All right. 5.999 minus 5.625 equals 0.374. Well, this 0.3 is bigger than 0.1, which means these are farther away. There is a bigger difference here. So this difference is bigger, which means it's farther away. Which rational number below is closest to that? Letter C. 5.5 was pretty close to this 45/8, which was 5.625. Summary says, what type of decimals can be turned into fractions? So this is a summary of actually the previous 2 lessons. There's a couple different types of decimals. What types of decimals can be turned into fractions? You go ahead and you can answer that summary on your worksheet. This has been lesson 0.2. Thanks for watching.